Welcome students. Today we can study different type of sets. Among different type of sets, first one is empty set or void set or null set. Empty set, null set, or one more name is that is void. A set which does not contain any element is called empty set, and which is denoted by the symbol phi. This one is a Greek letter, or this can be represented by in this way also. You have to start the curly bracket and you have to close. Okay. Now example for an empty set. A equal to set of all x such that x belongs to n and 1 less than x less than 2. That means you have to write all natural numbers between 1 and 2. Is there any natural number between 1 and 2? There is no natural number. So this one is example for null set. So you can write as this. You have to start the curly bracket and you can close it. Okay. And the example for null set. B equal to set of all x such that x belongs to n and x square minus 2 equal to 0. That means you have to find out natural numbers satisfying this equation. For that you have to solve the equation. X square minus 2 equal to 0 implies x square equal to 2, right, which implies x equal to plus or minus root 2, plus or minus root 2, and is not a natural number. That means there is no natural number satisfying this condition. That means this is another example for empty set. We can represent it by the symbol phi. Okay. Now second type of set, that is finite set. A set which is empty or consists of definite number of elements is called finite set. It can be empty or should consist of definite number of elements. Okay. For example, A equal to set of all x such that x belongs to Z and 2 less than x less than 8. That means all integers between 2 and 8. What are the integers between 2 and 8? So 3, 4, 5, 6, 7. There are 5 integers between 2 and 8. Actually there is a definite number of elements. So this one is example for finite set. A equal to, we can write n of a. N of a means number of elements in a. Number of elements in a equal to 5. N of a should be a definite value. It can be 0 or a definite value. Okay. Now third one, infinite set. A set which consists of infinitely many elements is called infinite set. There should be infinitely many elements. For example, A equal to set of all x. X belongs to n. Okay. And x greater than or equal to 2. That means you have to write all natural numbers greater than or equal to 2. So we can write like this: 2, 3, 4, 5, 6, etc. How many elements are there? There are infinitely many elements. So this one is example for infinite set. Okay. Now fourth type, that is equal sets. Two sets A and B are said to be equal if they have exactly same elements. Exactly same elements. For example, consider one set A. A equal to set of all x such that x is prime factor of 6. This one is first set, and let B equal to another set, that is set of all y such that y square minus 5y plus 6 is equal to 0. Y belongs to n. That means all natural numbers satisfy this condition. First we can represent A in Rosser form. So all prime factors of 6. So this 2 and 3, right? Now in order to find this answer, you have to solve this quadratic equation. Y square minus 5y plus 6 equal to 0. You have to find two numbers, product equal to 6, sum equal to minus 5. Numbers are minus 2 and minus 3. So y minus 2 into y minus 3 equal to 0. So y 2y equal to 3. So B elements are 3, 2. Actually these two sets containing same elements. So A is equal to B. Both consist of exactly same elements. Okay. Now next type of set, that is equivalent set, not equal, equivalent. Two finite sets A and B are said to be equivalent if they have same number of elements. Not same elements, same number of elements. Okay, for example, A equal to 1, 2, 3 and B equal to 5, 8, 9. These two sets are actually not equal, but they are equivalent because both contains same number of elements. N of A, number of elements in A should be equal to number of elements in B. Then we can say that two sets are equivalent. All equal sets are equivalent, but all equivalent sets are not equal. Among the different type of sets, last one, that is singleton set. A set consists of only one element. Only one element is called singleton set. One element. Okay, for example, A equal to set of all x such that x belongs to n and 2 less than x less than 4. That means all natural numbers between 2 and 4. There is only one natural number between 2 and 4, that is 3. So A consists only one element. This type of sets are called singleton set. Okay. We discussed different type of sets: empty set, finite, infinite, equal sets, equivalent sets, singleton sets. Okay. So now we can do some problems. Which of the following are example for empty set? Consider first question. A equal to set of all x, x belongs to n and x less than 5 and x more than 10. That means you have to find natural numbers less than 10 and more than, less than 5 and more than 10. Is there any such a natural number which is less than 5 and more than 10? Number should be less than 5 as well as more than 10. There is no such natural number. So this one is example for empty set. So we can write like this, empty set. And second one, B, X is a student of your school, presently studying in both +1 and +2. You cannot study both together in +1 and +2. So this is another example for null set. And third one, X is common point to any two parallel lines. Is there any common point between two parallel lines? There is no common point. So this one is third example, or this question is empty set. Example for empty set. Okay. Consider next question. Which of the following sets are finite or infinite? First question, set of days of a week. Clearly there are finite number of days. So it is example for finite set. Okay. Second one, set of circles drawn in a plane. We can draw infinitely many circles in a plane. So this one is infinite set. Third one, set of consonants in the English alphabet. Clearly there are finite number of consonants. Okay, so this one is example for finite set. And fourth one, set of all x, x belongs to n and x equal to 5n. Here x means it is multiple of 5. When n equal to 1, 5, and then 2, we get 10, 15, 20, etc. So there will be infinitely many elements. Okay, so example for infinite set. And fifth one, set of all x belongs to n such that x equal to 10 raised to n less than 5. One condition is there, n less than 5. So elements are 10 raised to 1, 10 raised to 2, 10 raised to 3, 10 raised to 4. There are only 4 elements. So example for finite set. Another question. In the following, state whether A equal to B or not. A equal to B or not. So First one is A equal to set of all x where x is a letter in the word loyal, Loyal. And second one is B, set of all x such that x is a letter in the word alloy. So first we can write A in Gaussian form. What about A? L, O, Y, A. We cannot write L two times. Okay. Now we can write Gaussian form of second one, that is B. B equal to letter in the word alloy. So A, L, O, Y. Actually A and B contains same elements. So A equal to B. Okay. Now second one. A equal to 3. Gaussian form is given. And B equal to set of all x. X is solution of x square plus 5x plus is equal to 0. That means you have to factorize this one. X square plus 5x plus 6 equal to 0. You have to find two numbers, product equal to 6, sum equal to 5. So two numbers are 2 and 3. So we can factorize this one as x plus 2 into x plus 3 equal to 0. Means x equal to minus 2 minus 3. So Gaussian form of B is minus 2 minus 3. So A and B are not equal. Actually A and B are equivalent because both contain same number of elements, right? So dear students, we can conclude today's section. In the next class, we can study a new topic, that is subset. Okay, thank you.